Hi, I'm Richard Griscom, and this is a video demonstration of the digital notebook method, which is a method for the rapid processing of elicited language data. And it uses only free software that is accessible for people with no programming background. And in this demo, we're going to be covering just two stages of the method. So what we're looking at right now is the digital notebook wiki page, which is hosted on GitHub. We'll go to the overview. We'll see that the digital notebook method has four primary stages. So there's the preparation stage, the elicitation stage, the recording stage, and the processing stage. So in this video demonstration, we're mostly just going to cover stage 3 and stage 4, because these are the two stages that differ the most from traditional elicitation methods. Okay, so we're going to be using files that you can also download from the wiki. So if we go back to the homepage of the wiki here, you can see under resources, there's a demonstration file. So if you click that link, then you'll be able to download the files that I'm going to be using in this video. And I'm also going to be using some free software. So the software includes Python, which you can get from this website. It comes with the idle development environment, which I will also be using. Next software is Prot, which is also free. You can download from here. This is software used for acoustic analysis. And the next software I'll be using is Elan, which is a tool that's designed for the annotation of video and audio data. I'll also be using LibreOffice just for creating spreadsheets. And then also I'll be using an IPA input keyboard that I downloaded from this SIL website here. Okay, let's go ahead and get started. So assuming that you have your software downloaded and installed, then the first thing you should do is download the demo files, which you see here. They're compressed together in a zip. So I'll go ahead and uncompress those. Okay, and there's our folder. You'll see that there are three files here. There's a spreadsheet file, there's an audio file, and then there's the data merger program, which in this case is in the form of a Python script. So the first thing that we're going to do is we're going to open the spreadsheet. So let's go ahead and take a look at that. All right, so you see that this is a very basic spreadsheet. What this is meant to represent is the end of the second stage of the digital notebook method. So at this stage, you've already worked with a speaker to create transcriptions and metadata. And this particular spreadsheet is a simplified elicitation session. So it only has 5 elicited items. So you can see these 5 English words on the left and their corresponding transcriptions in this next column. So what we're going to do now is move into the recording stage. And to prepare for the recording stage, the first thing that you need to do is create a recording page or recording spreadsheet. So to do that, we're going to use this spreadsheet as our foundation. So we'll just select everything and copy it. And we're just going to make a new spreadsheet, or a new sheet within this spreadsheet file. Then we're going to delete the top 5 rows because we don't need those for data processing. And then all that we're left now are the English translations and the transcriptions that correspond to each of those translations. So as you're entering into the recording stage, you want to prepare your speaker for the recording. The way that you're going to do that is going to train them to make sure to expect what you would like them to do during the recording in terms of repetitions of elicited items or the use of container phrases. So aim to have the speaker produce exactly the same items that you see in the recording page in the same order. And after you've done some training, when the speaker is ready, then you can go ahead and begin recording. Now during the recording, if you notice that the speaker deviates from the list in the recording page, you could take a note on the side over here, for example, like too many repetitions. Or you could actually make changes to the data on the left, say if they produce the words in a different order or something like that. You want to try to get this spreadsheet to reflect the recording as closely as possible. And if there were no deviations at all, or if you could make the appropriate changes, then you can go ahead and save this page as a tab-delimited text file. So I'm going to go to File, Save As, and the format here will be text CSV. The tab-delimited file can be in a .csv or .txt format. Either one is fine. So go ahead and save that. And one thing that you do want to make sure about is the delimiter should be a tab. So it should be a tab delimited text file. It should not be a comma separated file. Okay. So now that we have saved that as a text file, we can go ahead and close this. We don't need it anymore. And we can now go to Prot, which is our acoustic analysis software. And in Prot, we're going to open up the audio file. So go ahead and choose Read from File. And we'll navigate to my demo file folder here and choose the audio file. So the first thing that we can do is just take a look at it. So it looks like we made a good recording. There are 5 elicited items, each of which has 3 repetitions. And the difference between the amplitude of the speech of the speaker and the amplitude of the speech of the researcher is quite significant, which will help in our automatic audio segmentation. So it looks like we've done a good job, and we can go ahead and proceed with our data processing. So the way that we're going to use Prot to automatically segment the audio is we're going to go ahead and close this window, and then in this main menu here, we'll select the file and then choose Annotate, then under Annotate to Text Grid Silences. And here you'll see that there's a menu with some settings. I'm going to modify these settings for this particular file. And in general, the settings that you choose here will depend on the file that you're processing. So it will vary depending on the amplitude of the speech of the speaker and also the rate of speech and various other things. So for this particular file, I know that the minimum silent interval duration should be 1.5. Also for my labeling, I want the silent intervals to be unlabeled, and I want the sounding intervals to have the label of 3 asterisks. Okay, now everything should be okay, so I'll just go ahead and click OK, and then it will process the data. So now you see it's created a text grid file here in the menu. So to take a look at the 2 of these together, you can select both of them and then click View and Edit. And as you can see here, Prot has successfully segmented the audio correctly. So each group of 3 repetitions has its own segment, which is labeled with the 3 asterisks. And all the other sections of the recording have segments that are unlabeled. All right, so now we want to save this text grid as a text file. So navigate back to our demo folder and save this text grid, which just has the 3 asterisks labeled for each of the 3 repetitions for each elicited item. Sorry, for each group of 3 repetitions. So we save that file, and now if we go back to our folder, we'll see that we've got our original spreadsheet, we've got our original WAV file, and we've still got the data merger script. But now we also have the text grid that we just created, and then also that tab delimited file. So the tab delimited file has the text data from our spreadsheet, and the text grid, it has the timecode data for those segments that we created. So now what we want to do is we want to combine these together, and we're going to do that with this Digital Notebook data merger script. So currently there is an executable file that is available for Windows users so that you don't have to use this Python script. If you're using a Mac or if you're using the Linux operating system, then you'll have to use Python. So the way that we'll do that is we'll open this script in idle, just the Python development environment. And you can see the contents of the script. You don't have to do anything with the contents. Just leave the contents alone. all you have to do is click Run, and then under Run, there's the option Run Module. That will run the script. And you can see that the script is it's giving you some information. It's giving you the input directory and the output directory, and it's asking for how many columns of text data. So in this case, we only have 2 columns. In the original spreadsheet, there was a column for notes, but we didn't fill out any notes. So for right now, we just have English translation data and then transcription data. So we'll just say that we have 2 columns. Then we want to give labels for our columns. So the first column, we could just call translation. And then the second one we could call transcription. Then go ahead and hit enter, and it will then process that file. Okay, so now it is complete. We can close the Python shell and close idle. We see that the script has created an output folder in our demo file folder. And in this output folder, we have our 3 output formats. There's the tab delimited text, which we can open with our spreadsheet software. Okay, and we see that this has unique reference IDs for each elicited item, and it has the onset and offset times, and then it has the original text data from our spreadsheet, so the English translations, and then also the transcriptions. Then that same data has also been formatted for prot, so we see there's a text grid here. We could go back to prot and open that up. So if you go to Open, Read from File, then navigate to the Output folder and choose the text grid file. And if you select the new text grid together with the original sound file, and then click View and Edit, then you will see that all of the data has been put together here. Okay, finally there's a third format, which is for the Elan software. So we'll navigate to Elan here, which I've already opened. And then Elan, we can open that file directly. Looks like I'll have to navigate to my demo file, my demo folder rather. Okay, here it is. I'm going to go ahead and sort my tiers by hierarchy. But you can see that Elan looks fairly similar to prot. It has some similar functionality in that you can align text data with audio data. It doesn't have the same acoustic analysis functionalities, but it does have increased search functionalities. So you can easily create a database that you can search across. So the digital notebook method is especially powerful if you want to build a corpus out of your data and then be able to search all of that text data together with the corresponding audio data. Okay, so that completes this demonstration. That was, again, the 3rd step and 4th step of the digital notebook method, the recording stages, and the recording stage and the processing stage. If you have any questions about the digital notebook method, feel free to contact me. Here's my email listed on the wiki, rgriscom@gmail.com. I look forward to hearing from you in the future.